Hello everyone. Today we're going to go over recursive sequence questions on the Algebra 1 Regent. And a lot of times when you get up to a question like this, it looks really daunting, and like you can't be like, it looks like another language, and that's what shuts people off to it all of the time. But it is not that difficult. You see this a sub n, and this whole thing right here, n times a sub n minus 1. Right now, I'm just going to highlight something. This is the prior term. All right, so if this is the prior term all of the time, you have to have the prior term to solve for the next term. So just going to go through this like one step at a time. So the first thing that they give you is a sub 1. So a sub 1 is 1. So you need your a sub 2 and all the way to a sub 5, right? So when you're rewriting the formula, and I'm just going to show you, a, and you see this n? Well, it's 2 now because we're looking for a sub 2. And then I'm going to put the n down, which is 2, because n is 2 in this case, because we're substituting the 2 in for n every time we see n. And then we have a sub 2 minus 1, because n is 2. 2 minus 1 is a sub 1. That's what this is right here. So I'm going to rewrite it, a sub 2, and I'm not skipping any steps because I don't want to confuse anything. 2 minus 1 is a sub 1. We already have a sub 1. A sub 1 is 1. So what I'm going to do is I'm going to rewrite a sub 2 times 2 and times 1, because a sub 1 is 1. So a sub 2 equals 2. All right, so now I have a sub 2. So now I'm going to go in a different color ink, and I'm going to do, now instead of n being 2, I'm going to do a sub 3. So a sub 3 is, now again, I'm following this, n is 3 times a, and then n is 3 minus 1. All right, so now a sub 3 equals 3 times 3 minus 1 is 2, a sub 2. You already have a sub 2. A sub 2 is 2. So now I'm going to go a sub 3 equals 3 times 2, because a sub 2 is 2. And then a sub 3 is 6. All right, so now we have a sub 3. We have to do a sub 4. I'm going to change my ink again. I'm going to go a sub 4 equals 4, because n is 4, I'm following this, times a sub 4, because n is 4, minus 1. So a sub 4 equals 4 times a sub 3. A sub 3 we already have here is 6. So a sub 4 equals 4 times 6. So a sub 4 comes out to be 24. All right, we're not done. We need a sub 5. That's where I'm going all the way over here. A sub 5 equals 5, following this, 5 is n, times a sub 5 minus 1. A sub 5 minus 1 is a sub 4. So I'm going to rewrite this. A sub 5 equals 5 times a sub 4. A sub 4 we already know is 24. So a sub 5 equals 5 times 24. And we'll get our calculator just to make sure 100%, 120. And there's 120. And a sub 5 is 120. That is all recursive formula is. That's a recursive sequence. That's all it is. They give you the formula. You just follow it to the letter. All right. So Another question on the Regents. Again, looks exactly the same except for this, which is right here. This is the recursive formula that they want you to use. And here is the prior term. Right? They want a sub 4 this time. They gave you a sub 1. So I'm going to put a sub 1 equals negative 3. So I'm going to just go along. I'm going to start all the way over to the left here. Instead of this n being 1, I'm going to look for a sub 2 next. That's the next term. Right? Then I have negative 3. I'm copying it down. A sub n minus 1. It's times. It's negative 3 times this. All right, so times a, and see n is 2. It's 2 minus 1. Close parenthesis. And then see this minus 2? We're going to minus 2. So now we're going to have a sub 2 equals negative 3 times a sub 2 minus 1 is a sub 1. A sub 1 minus 2. I'm not skipping anything because I don't want to confuse myself. Negative 3. A sub 1 is negative 3. They gave it to you. A sub 1 is negative 3 times minus 2. All right. If you want to put this into your calculator, it's negative 3 times negative 3. Negative 3 times negative 3. Close parenthesis, minus 2. And it's 7. Negative 3 times negative 3 is a positive 9. 9 minus 2 is 7. A sub 2 equals 7. Now we're going to go to a sub 3. Instead of the n being 2, it's 3 now. So a sub 3 is negative 3 times a sub n minus 1. The n is 3 in this case. And then minus 2. So a sub 3 equals negative 3 times a sub 2. A sub 2 because 3 minus 1 is 2. A sub 2 is 7. A sub 2 is 7. Negative 3 times 7 minus 2. Now you can put this into your calculator. You would get negative 3 times 7 is negative 21 minus 2 is negative 23. All right, so let's just check it out though. Negative 3 times 7. You don't want to leave anything, and then minus 2. Anything to chance. You don't want to leave anything to chance. It is negative 23, and we're going to put that down. That's a sub 3. One more term, and we got our answer. So we're going to go to a sub 4. I'm changing the ink color. So a sub 4. Not that that matters. Whatever. Negative 3. We're going to use the same formula. The 4 is the n. The n is 4 now. So times a sub 4 minus 1. That is the prior term. The prior term is 4 minus 1, which is a sub 3. A sub 3 is now multiplied to by negative 3. So negative 3 times negative 23 minus 2. Whatever that is should be our answer. So I'm going to bring up the calculator again. I'm going to try to bring it up. This is negative 3, parenthesis, negative 23, close parenthesis, minus 2. And let's see what that is. That is 67. So a sub 4 equals 67. And we are finished with our problem. That's all they wanted. They wanted a sub 4, and that is 67. That's it. Follow it step by step, just like I have down on the page, and then you'll be okay. So here's another recursive sequence. This is the latest Regent that was given in January of 2023. It's number 21, another multiple choice question. So a sub 1 is 3. A sub n equals negative 4 plus the prior term. Which representation yields the same outcome as the sequence defined recursively below? First off, I'm looking at this right here, and I'm not thinking it's 3 and 4. Okay, these are linear. This is a recursive sequence, and I'm thinking that's not it. So I'm not going to cross them out yet, but I'm kind of keeping an eye on 1 and 2, because a sub 1 is already 3. So I have 3 here and 3 here. That looks good. Okay, so now let's go. So we have a sub 2. This is the next term. That's your a sub 1, which is 3. A sub 2, n is 2. So see, look, I'm putting it there. Now it's negative 4 plus a, and then the n is 2. Look, 2 minus 1. 2 minus 1 is a sub 2 equals negative 4 plus a sub 1. A sub 2 equals negative 4 plus 3, and a sub 2 equals negative 1. Now, I know that that's my a sub 2. This is out already. This is gone. All right. So I'm just going to look and to see if it's negative 5, the next one, I'm going to pick 2 as my answer. But if I went all the way through, I should get all of these numbers, negative 9 and negative 13, if that's the answer. So let's go ahead and do a sub 3. A sub 3 equals negative 4. I'm following this formula here. Now instead of the n being 2, it is 3. So it's negative 4 plus a sub 3 minus 1. A sub 3 minus 1 is a sub 2. A sub 2 is negative 1. Negative 4 minus 1. A sub 3, negative 5. And that is definitely my answer. Let's go ahead and see if we could do a sub 4. A sub 4 equals, now 4 is my n. So I'm going to put 4 here. I'm going to put 4 here. See how that's the prior term? 4 minus 1 would be 3. So now it's negative 4 plus a sub 3. A sub 3 was negative 5. So a sub 4 equals negative 4 plus negative 5. Negative 4 plus negative 5 is negative 9. 2 is definitely my answer. Right? That is it. You just have to follow the steps one by one and then get that sequence down. The other type of sequence they might throw at you. This was on the January 2023 Regents number 21. So they had 2 sequence questions here. This is called a geometric sequence. And you could see that they give you the geometric sequence formula right on the reference sheet. So you look at the reference sheet and you look at the formula and you're going to go, okay, it's a sub n equals a1. A sub 1 is the first term. Here it is right here, a sub 1. A sub 1 is the first term. And then r to the n minus 1. So you're just going to have to, if you want to use the formula for this, you could use the formula. If not, if you're like me, I could just look at this and say, okay, the common ratio is negative 3. So that means that I'm just multiplying by negative 3. So look, this is the short way without the formula. I'm looking at the formula. I'm like, I don't need it. First term is 4. My common ratio is negative 3. So what's 4 times negative 3? Negative 12. Okay. A sub 4. A sub 3. Negative 12 times negative 3. Negative 12 times negative 3, 24 negative is positive 36. Then 36 times negative 3. I don't want to make a mistake. Negative 108. So this a sub 3 is negative 108. And then let's see the a sub 4. Negative 108 times negative 3. $324. And I rewrote it over here to make it a little bit easier to deal with and to actually make sense. I'm just multiplying by negative 3 to get negative 12. Negative 12 times negative 3 is 36. Positive 36 times negative 3 is negative 108. And then so on and so forth. Negative 108 times negative 3 is 324. 324 is my answer. By the way, you could use the formula. There is no problem with that. And this is how you would substitute it into the formula if you wanted to. A sub 2. See, this n is 2 now. And then this a sub 1 is the first term. So that's going to be your 4. Times r, which is negative 3. This is your r, the common ratio. And then n minus 1 is 2 minus 1 is the n, which you're looking for, n minus 1, because that's part of the formula there. So you have a sub 2 equals 4. Put everything in parentheses, times negative 3 to the first power. 2 minus 1 is 1. A sub 2 is negative 12. And that's what I have. That's what I have. Then if you wanted to go to a sub 3, now the n is 3. Let me get this out of the way because it's confusing now. The first term is always 4. The first term is 4. Times r. The common difference is always negative 3. And then n minus 1 is 3 minus 1, so it's squared. You put this directly into your calculator and you get 4 times 9. And 4 times 9 is 36, so 8 to the third is 36. And you keep on going just like that. Whatever way you want to do it, if this is an open-ended question, use the formula, show it like that. Or you could use it this way. That would be, this would be full credit as well. All right, just remember, geometric sequence, you're multiplying, and they're giving you the first term, and they're giving you the common ratio. It's just multiplication. That's all it is. They could have said the first term was 10. And it would be 10 times negative 3. The second term would be negative 30. All right, so just take your time, use the formulas. They're there. For the recursive formula, they give you that recursive sequence. They give it to you all of the time. Write it down like I did. Just making sure. Okay, ask yourself, define n. N is the actual, I think this is the better one over here. N is what I'm looking for. Start off with a sub 2. A sub 2. 2 is n. So every time you see an n in this sequence, this formula right here, every time you see an n, okay, I'm going to substitute the n. I'm going to substitute the n. And then just rewrite it. Go step by step. Don't skip. Don't rush. And that's basically it. I hope that helped. Thank you for watching. See you next time.